Hello and welcome to the first of several segments introducing the Maxine Inspector, an all-in-one visual debugging, analyzing, and browsing tool for the Maxine Research Virtual Machine. As we said in the introduction, this is a tool specialized for the Maxine VM development, and I'd like to show you some of the features and show you how it can actually improve your development productivity. You'll see behind me a full window which contains a number of panes, each of which describes part of the state of a running virtual machine. We're going to zoom in and look at one particular feature right now, and that feature is the description of the boot image that we're actually starting with. The way the Maxine Virtual Machine starts is with a carefully constructed binary image designed for a particular target platform, and that is mapped into the memory space of the new process, and we'll see exactly what goes into one of those boot images here. So I'm going to come up to the View menu now and pull down the boot image view, and this will tell us a little bit about how the virtual machine starts. Okay, so this particular boot image was designed with extra debugging in it, and it was prepared for a AMD 64 processor with particular hardware architectural features you'll see listed. The boot image can actually be cross-developed on one platform and targeted for another. This image was also designed for the Solaris operating system, although we do support OS X and Linux as well. You'll see then what follow are a collection of specified schemes. Each scheme is a collection of Java code that implements a specific interface that represents a piece of functionality in the running virtual machine. This is how we do research with the Maxine Virtual Machine. We experiment with alternate implementations of the schemes. This is one of the examples where writing the virtual machine entirely in Java gives us tremendous advantage because we can use interfaces to great advantage. You'll see also schemes, as I mentioned, for everything from object layout to memory management, garbage collection, compilation, runtime optimization, including even the Java run scheme. That's an interesting one because this specifies what happens when the virtual machine comes up, and in this particular case the default is that it runs an ordinary Java program, but we actually have flexibility to change that as well. Farther down you'll see some data about what's in the binary image as well, and one of the things that's in it is a complete heap with all the Java objects necessary to run and execute the Java virtual machine as it's written in Java. There's also a pre-computed code region as well, and these are in the same format as the more dynamic runtime. So when the virtual machine comes up, after a little bit of memory relocation, a branch is taken into a critical location, and those are mentioned here as well. You'll see the VM startup method. And away you go with a full running Java virtual machine, completely, and using meta circularity, implemented in itself completely in terms of objects. That concludes this particular segment. In subsequent segments, we'll look at other individual features of the inspector one by one. Thanks.